Here's a wall. Here's my ladder. I don't know why I dotted it, but it's sliding down. So the ladder starts up here and it's moving down. The distance between the top of the ladder and the foot of the wall, I mean, imagine that's this right here, is decreasing at a rate of 9 inches per second. So we'll call this distance x. X changes depending on how long it's been sitting there. So x prime is this distance, how fast it's changing with respect to time, specifically seconds. So x prime is -9. And the reason why I'm putting negative instead of positive is because x is decreasing, right? So -9 says that the rate of change of this distance is getting smaller by 9 inches per second. And they tell us when the distance is 61 inches, how fast the distance between the bottom of the ladder. Oh, maybe I've misinterpreted. Hold on. Top of the ladder and the foot of the wall. No, that's right. When this distance is 61 inches, so when x is 61 inches, how fast is the distance between the bottom of the ladder, which is this, I guess, and the foot of the wall changing? Oh, because this is moving away, right? So if the ladder is moving down, then it's getting pushed further and further away. So we expect our answer to be positive. How fast is this distance changing? Or actually, specifically, it's from here. Here, let me draw it with a different color. How fast is the distance between the bottom of the ladder and the foot of the wall changing? So how fast is this changing? We'll call this distance y. We don't know what it is. But they're asking us for y prime. How fast is that ladder moving away? Because after a few seconds, it's getting further and further away until it's completely horizontal. Okay, and then they tell us the ladder is 152 inches long. So this is 152 here. Okay, I think we have everything we need. The first thing you want to do is set up an equation that models the things that we don't know. Like how long this distance is depends on time, right? Depends on some unknown variable t. And how long is this distance? That also depends on how long this ladder's been falling down. But we can say that x squared plus y squared always has to equal 152 squared because it makes a right triangle. And now we want to know something about the rate of change of this distance here. So we want to take a derivative with respect to time. But this needs implicit differentiation both for x and for y because we don't know what those variables are with respect to time. So we'll make that 2 come down and multiply. That gets reduced by 1. But then look, this isn't a derivative with respect to x. This is a derivative with respect to t. So we don't know what x is with respect to t. So I'm going to put x prime here. And the 2 comes down and multiplies. And then again, we don't know what the rate of change of y is with respect to time, so we use y prime here. And then the derivative of a constant is always 0. Okay, so now if we plug in our given information, this distance is, oh, okay, so here, we know what x is. We can plug in 61 in for x. We know x prime is constantly -9, so we can plug in -9 in for x prime. Now y, we're not directly given y, but we can find it out because at this instant, x is 61. And since the ladder is always 152 feet, that ladder's not shrinking. That ladder's the hypotenuse. We can solve that equation for y. 152 squared subtracted by 61 squared. Makes that, and then take a square root. Oh man, I did this wrong last time I did this problem too. Okay, that's 152 squared. This is 61 squared, so 3721. Sorry, 372. And now take a square root. So that's what y is when x is 61, when that x distance is 61. And so we can plug that in for y into our equation. And now you have just one variable. Now you can solve for y prime, right? So I'll take this step by step. 2 times 61 times -9 is -1098. And over here, 2 times all that mumbo jumbo. Forgot what it was. There it is. That's y prime equals 0. So if I'm trying to get y by itself, I'm going to erase this because we're done with that. Okay, so if I'm going to get y by itself, I want to add that 1098 to both sides. The last step is to divide that 278 from both sides to get y prime by itself. So y prime, we got 3.94 to the nearest hundredth. So it's moving at a rate, it's increasing at a rate of 3.94 inches per second.